Question 12, consider the square ABCD, you can see here in the diagram, and find the image of the point A under. So A under, and it's always about the origin in these questions. Positive rotation of 90 anti-clockwise, so it's going down this way. So A would have to end up at D for positive. A positive rotation of 180 it would do another one. It would end up at C. 270 would end up at B. Third one around, sorry, B. And rotation of 360 would get it all the way back to the start again to A. Nice easy start. In how many different rotations of the square ABCD about the origin between 0 and 360 inclusive will the image fit exactly to the object? Well, because it's a square, if B ends up over at A ends up at D ends up at C, and C ends up at B. So that's going to happen 4 times. So the answer to this one will be 4. So they're not really trying to trick you here. The answers are fairly obvious. In how many different rotations of each of the following shapes about the point O does the image exactly fit over the object? And we're dealing with the shapes here, A, B, C, and D. In how many different rotations of each object does around the point O does the image fit exactly over the object? Okay. Look at it like this, like the symmetry here. There's 1 for A. That's what they're looking for. Within an equilateral triangle, there's 3. 1, 2, and 3. In a rectangle, there's 2. That's what they're looking for here. That's when they will map each other when they're around like that for the second time. And in the fourth one here, the 2 diagonal lines will give us symmetry. So there will be 2. So 1, shape B is definitely 3. Shape C looks like 2 unless I'm missing something. And shape D also looks like 2. For question 13, in each case identify the transformation. Is it axial symmetry in the x-axis, axial symmetry in the y, or central symmetry in the origin? That maps. So first of all, image A onto image B. So what's happening between image A and image B? That point is going to there through the origin. So it's going through the y-axis and it's going out the same distance to the other side. So we definitely here have axial symmetry. I'll just write in y-axis, axial symmetry in y-axis, this guy. Axial symmetry in the y-axis, D to C. D to C. So here's the top of his head. It's going D to C. He's going that way in the same distance to the other side, it looks like. So again, it looks like also axial symmetry in the y-axis. Has to be. A to D. Okay, just get rid of these lines. A to D. We're going through the origin here. Here's the bottom corner. That goes to there. So we're going through the origin and directly out the same distance to the other side. We know from before that's central symmetry in the origin. Central symmetry in the origin. Just keep on writing in the origin. Do they have it? They do. Symmetry in the origin. They have it there. And then B to D. Well, B to D is through the x-axis. So I think that's the only other option there, isn't it? We don't need to worry about that. It's just symmetry in the x-axis. Axial symmetry in the x-axis. Has to be. It can't be anything else. Could be a rotation around a few times, but we're looking at axial symmetry here in the x-axis for D. And then finally in this video, question 14. In each question below, the 3 images labeled A, B, and C are images of the object under a transformation. The transformations could be any of these: translation, axial symmetry, or central symmetry. For each image, which transformation is used? So what has happened to the bird here? His feet were pointing south. This is what looks obvious, and they're now pointing north. So it looks like he has been rotated in that direction. A positive rotation 180, which is central symmetry. This one here, central symmetry. Central. Object B, we've got the guy's head here. So for this guy, he's also just looking at going from there to there. That's axial symmetry. He's just going through the x-axis for A. This is axial. And this object, what's happening between this guy and A? Well, that's just the same direction, same distance. So this is a translation. Back up to the bird. So between this guy and B, well, between this guy and B, the same as part A for the second one. This is axial. He just has gone through the x-axis from here to there, through the x-axis, if we imagine that. And sticking with C, this guy here has just moved in the same direction. So translation for C. B, this guy has just moved from here to here, translation for B. So this one's a translation. And then C, well, C, he has gone through the axis and turned around. He has flipped the opposite direction around. So that is central for this guy here. Upside down, back to front. Have we an upside down, back to front for this guy? Third guy, we do. This guy here is upside down, back to front. This one, so that's also central. So is that one. And part C is axial for this guy. You can see that clearly, that this is axial. If there was an axis there, that red line would come down the other side and we would have symmetry. So transformation geometry, hopefully you're mastering this topic.